This is our second lesson on controlling costs using earned value management. We will build on the three terms we learned in the previous lesson: plan value, earned value, and actual cost. We used a simple example to show how we roll up activity data to get PV, EV, and AC. This is our simple project plan with activities scheduled and estimated. The total PV is 1,000. That is the same as another key term, budget at completion, or BAC. We can actually roll up the PV for every day. In our notation, the PV for the day is on the top and the accumulated PV is on the bottom. So when we say plan value, we really mean at any day in the project. How much scope had we planned to accomplish by that date, and what had we planned to spend on those activities? Now, let's take a deeper dive into the status on day 3. 6 activities are complete and one is 50% done. They have accomplished $650 worth of work. Notice that our day 3 accumulated PV is 600. Compare what we have accomplished with what we planned to accomplish. That is your schedule variance. This is where earned value management really provides a unique insight. It uses cost to explain our schedule performance. An even better way to use cost to measure schedule performance is to divide EV by PV. That gives us a schedule performance index. Divide 650 by 600 and you get an SPI of 1.08. An SPI greater than 1 says that you are getting scope completed faster than originally planned, and therefore the project is ahead of schedule. Cost performance is pretty intuitive. Record the actual cost of the activity, then roll it up so that you have the actual cost as of the status date. Here, that is 690. The key question for evaluating cost performance is, for the scope that has been accomplished, are you spending more or less? Compare earned value to actual cost to determine the cost variance. In this case, the variance is negative, so it's over the planned cost. The cost performance index shows how close we are coming to our estimates. Divide earned value by actual cost to get the CPI. Here, our CPI is 0.94. CPI less than 1 is overrunning the cost baseline. When you encounter earned value problems on the exam, they may list all the information we've been seeing in a table like this. There is a column for every one of the terms we've discussed. The status date will be clearly indicated in some way. This format actually makes it easier to total up PV, EV, and AC. If you are given plan value and percent complete, you may have to calculate earned value. Why is earned value so important? It's project accounting. Let's change a few numbers on our example to make our point. We've added one more task that is complete and changed the actual cost for some of the activities. Project accounting is different than financial accounting. Financial accounting compares the amount spent in a time period to the budget for that time period. In this example, we are taking status after 3 days. In the first 3 days, we had planned to spend 600, but we actually spent 750. To someone using traditional financial accounting, that might look pretty bad. But we don't compare plan value and actual cost. We compare earned value and actual cost. Using our project accounting technique, we see that our project is ahead of schedule and on plan for cost. That's an accurate and useful understanding of the project. What we've seen so far is that the purpose of earned value management is to provide a project-level summary of cost and schedule status. This is a good time to remember which cost target we are using. The cost baseline, which is the cost component of the performance measurement baseline, is our target. Even though the term is budget at completion, it really means the total plan value. This status is a measure of performance at a point in time. Recording status on a regular basis will show trends. Both cost and schedule can be over, under, or on plan. To illustrate, let's graph our cost and schedule performance on two axes. The intersection will be on plan, which is a CPI and SPI of 1. Now, we have 4 quadrants. Each represents a combination of cost and schedule performance. The upper right is good, ahead of schedule, and under the cost baseline. The SPI and CPI are both over 1. Schedule variance and cost variance are both positive. The lower left is bad, behind schedule and over the cost baseline. CPI and SPI are less than 1, and cost and schedule variance are negative. The other 2 quadrants are mixed. We can summarize that positive variance is good and negative variance is bad. And we want CPI and SPI to be over 1. To summarize our first 2 earned value lessons, once we begin to execute our plan, we can generate PV, EV, and AC for a specific status date. A new term in this lesson is budget at completion, or BAC. That is the plan value at the finish of the project. Schedule performance is measured by comparing earned value and plan value. Cost performance is measured by comparing earned value and actual cost. Here's a formula memorization tip. In all these calculations, EV is on the left. In general, being under the cost baseline and ahead of schedule is good, and being on plan is the best.